Okay, I was going to reflect this point. If I reflected this point actually corresponds to this point, and I sketched this by hand and made it a little too fat. This point doesn't reflect well to give us a point in the vicinity of this one. So what I want to do is I actually want to reflect this point in the most appropriate way. And I'll just observe, there are other ways to look at this, but I'll just observe that if I project this point over here, I get a point here, and it should be clear that this point is symmetric with this one through the y-axis. And should give me a point over here. If I subdivide this segment corresponding to the points in this quadrant, then this point will correspond to this point here. And you want to think through that. I'm not going to go through every detail of it, but let me show you how we would construct that point based on the points that we've constructed here in our first quadrant. What I do is I'm going to reflect every point of this arch of the sine curve through this point. And I do that as follows. I sketch a line segment okay, if I'm trying to reflect this point, I sketch a line segment through here down to here. And then I don't, well, I have two options. Okay, I can locate the point that lies this far below the axis here. But that's going to be kind of tricky because I don't know exactly when I'm that, you know, I don't have a good perpendicular here. Okay, I could construct one, but it would be difficult to locate the point here that's an equal distance below the y-axis along a perpendicular to this. So I'm not going to do that. And of course I don't have a compass big enough to do what I'm going to do. I'm going to use my fingers to indicate a compass. Well, I can take this distance here and measure the same distance here and get a point here. Now if I've done that accurately, this point will lie at a perpendicular below this point, assuming that this point has been constructed by subdividing this interval twice. So I subdivide to get this point, then I subdivide this subinterval to get this point, and this interval to get subinterval to get this point. Okay? Now, you should really understand in detail regarding, in relation to this graph, how we get this point. I can do the same thing with every other point on this part of the graph. Okay, so I can construct I can draw this line. Okay, I can draw a line here. I can draw, let's not press our luck, I'm going to draw a line through this point and this point. Then, if I mark the points, again, using my finger compass here, from this point to here, same distance along this line gives me a point here. Doing the same thing here. We get a point here. And of course, if I want to project, no, let's use a longer straight edge. If I want to project or reflect this point I do the same thing. Do this. Okay, I get this and this. It gets me pretty close to the point that I marked down here. That's going to be this point. Now, if that construction is completely accurate, this point will lie directly at a perpendicular below this point here. Not quite, but pretty close. Similarly with the other points. And then what I will get is going to be a reflected version of this curve. If I do that for every point on this curve, if I've constructed this curve accurately, I'll get a curve here. Now I can't really show the constructions here because I didn't construct these points. I sketched it. Again, I made the curve too fat. It's not going to project as nicely as it should, but it will, if constructed correctly, project in such a way that it extends and gives us a nice graph of the sine function.